Hi everyone. This short video has been produced to help with questions that may appear in the SQA, the Scottish Qualification Authorities exam for the Higher Physics course. So in this video we will be looking at particles and waves, that section of the course, and we shall be looking at refraction. So here's a question on that might appear in section 1 of the exam paper. A beam of red light of wavelength 700 nanometers is shone into a beaker of water. The water demonstrates the same refractive index as sodium light at 589 nanometers. What happens to the beam of light and what speed is it moving through the water? So some important things here. We know it's red light. We've been told it's 700 nanometers. Its refractive index is the same as sodium, even though it's going into water. And then we want to figure out what happens to that beam and what speed is it moving at. We're given the usual options, A to E, and a chance to maybe knock some of those out. If we read the question closely, we pick out the things we're being asked about, just as we did, and we can look to see if there's any options that are obvious that we can ignore. Well, common sense, which is not something I encourage in a science examination, but suggests that when water passes into your glass, when light passes into your glass of water, does it usually change color? No. So that maybe suggests that red light going in will stay red light in the water. And in that case, we can maybe knock out 3 of the 2 answers, potentially. Anyway, try and recall what part of the course is being referred to. Read the question slowly and read it again in your head just to make sure you get the main points. But if you are getting lost or confused, you've maybe overread it, so perhaps move on to a different question and come back to this one, or just take a pause and read it again. And keep in mind that they are only going to test you on things that you have read about or that you have been taught. So here we're thinking about what happens when light passes from one thing into another. The course materials calls this Snells Law, and if you can recall that, you're off and running straight away. But we could look at the question, if we can't recall that, to see that we've been given a wavelength for light, and we're also told about water's refractive index being the same as sodium. So we must be told that for a reason, and perhaps it's pointing us at the data sheet to check if there is a refractive index for water given in there. And indeed, there is one, and we can see that it's 1.33 for water, which is the same as sodium at 589 nanometers. Now, just on the off chance there's something useful, and a useful equation in the data sheet as well, we can look to see if there's anything that relates n, the refractive index, to speeds. And hey presto, there is indeed. We can see that n is equal to the ratio of 2 angles, or 2 wavelengths, or 2 speeds. So we know n, and we know, because it's in the data sheet as well, that the speed of light through air or through a vacuum is c, 3 times 10 to the power of 8 meters per second. That should allow us then to calculate the other speed, the speed that it is in water. But what about the colour change element? Well, again, we should be recalling from the course material that colour is due to the frequency of a wave. The frequency isn't being changed, so the colour should stay the same. And like I said, we could think about common sense. If you shine a light through the water, does that light change colour in the water? No, not in your everyday experience, which means we're probably looking at either A and B as being our correct answers. So let's take a look. We know the formula we need to use, n equals v1 over v2. That's the speed of light in the thing to begin with, and then v2, the speed of light in the substance it's gone into. So we can pop those in. 1.33 equals 3 times 10 to the power of 8 over the speed that's in water. Then we just have to do a rearrangement. And if we rearrange that and calculate the answer and match it up with the fact that the colour stays the same, then we find that A is the answer, and well done if you got that. So what are the key things to note here? Well, if we can recall Snell's law from the course, brilliant, that's off and running. But we can also use a bit of common sense about the colour change element and then search through the data sheets for constants and equations that might help us. Try not to be thrown by the other numbers in the question. It mentions sodium and a wavelength. that's there to point you at the data sheet rather than be useful information for the calculation. So in your questions, they're probably either going to be one of those two things. So if you're not finding a place for it in an equation, then maybe check the datasheet to see if it's a datasheet reference instead. Sometimes drawing a diagram can help. That beaker and two arrows might recall something in the course where your brain just snaps and says, oh yeah, that's what I need to be looking at. So sometimes a diagram can be very helpful, just scribbled at the edge of your exam paper. Here are some other questions on the topic to give a try. Pause the video, give them a try, see what you come up with. Answers on the website. And finally, thanks very much for watching.